Hello and welcome to the Chapter 3 podcast on Section 3.3. Today we're going to be discussing formula weights. We can refer to atomic weights when we're talking about molecules and formulas in terms of formula weight or molecular weight. Remember, formula refers to formula units, which we're talking about ionic compounds. And remember, ionic compounds are made up of metals and nonmetals. Molecules are referring to covalently bonded compounds, and these are made up of only nonmetals. Sometimes you might see molar mass in conjunction with formula weight or molecular weight, and they're going to end up being synonyms in terms of how they're done. What will make them a little different is the mass, the way the mass unit is treated. So if I want to calculate a formula weight, let's say I ask you to calculate the formula weight of H2SO4. If I want to know the formula weight of H2SO4, I'm looking at the composition of the formula. So H2SO4 is made up of 2 hydrogens, a sulfur, and 4 oxygens. And this is just a breakdown of the chemical formula. If I substitute in the atomic weight of each element that shows up in the formula, so for hydrogen it's about 1 AMU. These are all rounded, by the way, and typically we'll round to the nearest tenth of an AMU. For sulfur, it's 32.1, and for oxygen, it rounds to about 16. And then when you multiply and sum up the products, 98.1 AMUs is the formula weight of H2SO4. And so we'll be calculating formula weights for other things, and this is something we'll practice a little bit in class. We can also take formula weights and we can figure out percent compositions. So what we can do is we can look at individual elements in a substance, and we can take the mass of that element divided by the weight of the compound, the formula weight, and multiply it times 100% to get the percent composition. So down here I have an example of this. So let's say I want to know the percent composition of carbon in C12H22O11. Well, first thing we would calculate is the formula weight of the compound, and that would be 12 times the mass of carbon plus 22 times the mass of and this is the atomic mass, by the way, of H plus 11 times the mass of oxygen. And so if we sum that up, it ends up being 342 AMUs. For carbon, the numerator would be the contribution of carbon's mass. So that would be 12 because of the 12 in the formula, and this 12.0 is the rounded atomic mass of the carbon. And then we divide it by the formula weight, and we end up with 42.1%. So 42.1% of the total mass is due to carbon for this particular formula. And we'll also be using it for other things as well later in this chapter. So until next time.